In this video, we're going to take a look at section 2.6, which is on finding linear equations. The first type of problem that we will encounter in this section will be a problem where they give us the slope and they give us the y-intercept. And this is really the easiest version of this problem that we could possibly get. So the formula you want to use for finding the equation of a line given the slope and the y-intercept is the slope-intercept form that we've seen in previous sections, y equals mx plus b. So this would be the formula that we want to use to do that particular kind of problem. So let's take a look at an example of that. All right. Find the linear function f of x equals mx plus b, whose graph has the given slope and y-intercept. So they are taking every opportunity to use the function notation because that opportunity is pretty rare in this course. They won't get to use it as often as they maybe would like, so they're going to throw it in here. But just remember, f of x is the y variable. So this is really just our slope-intercept form that we just saw on the screen, y equals mx plus b. And notice they already have that typed on the screen here. Let me try that again. So we don't have to type it in ourselves. We just type in the right-hand side of the equation that we're going to find. The details we're given are the slope is negative 9/5 and the y-intercept is 0, negative 2. And so they're really telling you all the numbers you need to plug into this formula to get the equation. Meaning there's no calculations to do, there's no computations, there's no work really. You just take the numbers, plug them into the formula, and you get your answer. Right? So this tells me that the slope is negative 9/5. And the y-intercept is 0, negative 2, which tells me b is equal to negative 2. Right, so b is the y-coordinate of the y-intercept. Right, so we take those numbers and we plug them into this formula. We have y equals mx plus b. We're going to plug in negative 9/5 for m and negative 2 for b, and we'll end up with y equals negative 9/5 x plus negative 2, which we'll write as minus 2. And that's all there is to that problem. For Math Excel, you're just going to type this part into the box. Right? So that's what you would type in here. It already has the y equals part on the screen. All right, so that's the first kind of problem that you'll come across. Now what's going to happen is as we move on to the different versions of this problem, the information they give us becomes less and less helpful. So we have to do more and more work to get the information we need to do the problem. So let's take a look at the next kind of problem we're going to have. For this next problem, they're going to actually give us the slope, but instead of giving us the y-intercept, they give us some other point. So a formula that you can use for finding the equation of a line using another point besides the y-intercept and the slope is this formula here, which is called the point-slope form. And it goes y minus y1 equals m times x minus x1. This formula is only useful for this situation. You never want to leave your answer in this form. That's not really a very good way to leave your answer, and it'll never be the way Math Excel is going to be looking for the answer. And so you'll have to do some post-processing, right? Once you get this formula set up, you'll have to solve it for y to get it in the proper form. So it's going to require a little bit of work. But what is nice about it is it has a place for you to plug everything in. So you can just kind of dump all your information into the formula, you get your equation right away, and then you just have to kind of work it down to set it up in the proper way. So let's take a look at an example of that. So find an equation of the line having the given slope and containing the given point. So they tell me m is equal to negative 4, and they give me this random point here, which is 5, 7, which it's important to note is not the y-intercept. If they give you the y-intercept, you should take advantage of that. That would tell you what b is equal to, and we would use the other formula we used earlier. This is not the y-intercept, and I can know that not just because they didn't label it as the y-intercept, but to be the y-intercept, the x-coordinate would have to be 0. Right? The y-intercept is going to be 0, some number. This is not 0, some number, so that's not the y-intercept. So b is not equal to 7. And I want to really emphasize that because I will get students on the exams where that's exactly what they do. They take whatever y-coordinate they can find and they plug that in for b. But b isn't just some random y-coordinate. It is the y-intercept y-coordinate. This is not the y-intercept. So we don't know what b is equal to. Right? So we'll use the formula we just talked about. We have y minus y1 equals m times x minus x1. And we will plug in, for the slope, we're going to plug in negative 4. And the point gets plugged in for x1 and y1. Make sure you plug it in the right order. The first coordinate is the x coordinate, so that'll be x1. The second coordinate is the y coordinate, that'll be y1. And that's what we'll plug in here. So we'll plug in 7 for y1, 5 for x1. And once you get all these numbers plugged in, you have your equation right away. That's the equation of the line. But the unfortunate thing is it's not in the right form. So we'll have to simplify it. So we'll have y minus y1, which is 7, equals m, which is negative 4, times x minus x1, which is 5. And that's the equation of the line that we're looking for. But let's go ahead and simplify it. You'll start by distributing the negative 4 into the parentheses. So you'll have y minus 7 equals negative 4x plus 20 when you distribute the negative 4. And then we're going to add the 7 over to solve it for y to get it in the slope-intercept form, because that's the way they want the answer in Math Excel. So we'll have y equals negative 4x plus 27 when we take 20 plus 7. And again, make sure when you type this into Math Excel, you don't type the y equals part again because it's already on the screen. You just need to type the right-hand side of the equation into the box. All right, so that's using the point-slope formula to find the equation of the line, given the slope and a point, some random point. Okay, so this problem is very much the same kind of problem, except this time the slope is a fraction, so that can cause a little bit of grief for us. So let's see what we can do with this. Find the equation of the line given this slope and this point, which again is not the y-intercept, so we don't know what b is equal to. So we'll go ahead and use the same formula, y minus y1 equals m times x minus x1. And we'll plug in the slope, which is 2/3. We'll plug in for x1, we're going to plug in 8. And for y1, we're going to plug in negative 6. So we have negative 6 for y1 and 8 for x1. So let's go ahead and get those numbers plugged in. We'll have to be careful here. Y minus y1, which is negative 6. So be careful. You get a double negative there. There's a minus sign in the formula, and then y1 is a negative number. And so we get two negative signs. So make sure you write that distinctly so you can see the two negative signs, because what that's going to do is become plus 6, right? The slope is 2/3, so we'll write 2/3 for m, and then we get x minus x1, which is 8. All right, so that's your equation, but we need to simplify it, and we'll start by taking care of the double negative. That makes it positive 6. We'll distribute the 2/3 into the parentheses, and here's where things get a little bit messy because it doesn't simplify very nicely. So we'll have minus, let me try that again, minus, okay, 2/3 times 8. You could try it in your calculator. You'll get a decimal, a run-on decimal, which we don't want to write in our equation. We want to keep it in fraction form. So let's do this off to the side. We're going to have 2/3 times 8. Think of that as 8 over 1. And what you do to multiply two fractions together is you just multiply across. Right? So you're just going to multiply straight across. You don't need a common denominator. So you'll get 2 times 8, which is 16, over 3 times 1, which is 3. So you get 16 over 3. That part wasn't so bad, but this is going to be the worst part right here. Now we have to solve this for y by subtracting 6 to the other side, and we're going to have to combine these numbers together, and again, it involves a fraction. So this time we do have to get a common denominator, right? So we're going to have negative 16/3 minus 6 over 1. The common denominator here is going to be 3, so I'll multiply 3 to the top and bottom to that. So we get negative 16/3 minus 18/3, which is going to give me negative 34. See, is that right? Yeah, 34 over 3. Right. And so that's what we get when we combine these two numbers together. So my final answer will be y equals 2/3 x minus 34 over 3. So I'm having to write it up here since I ran out of room down here. All right, so again, the plus 6, the minus 6 cancels out. The 2/3 x just gets copied over. And then combining these two numbers together, we get 34 over 3. And so that would be the equation of this line. And so that's kind of worst case scenario for this type of problem, given the slope and some random point, having some tough fractions to deal with. Okay, let's take a look at the next kind of problem. So here's where they're going to amp it up a little bit. This time, they don't even tell us the slope. They give us 2 points and that's it. And neither one of them are the y-intercept. So find an equation of the line that contains the following pair of points. So if I want to use this formula, y minus y1 equals m times x minus x1, I need a point to plug in for x1 and y1, and I have 2 to choose from. We could use either one, it doesn't matter. But I also need the slope. Right? So before I can get started with this formula, I need to know what the slope is equal to. And they don't tell me the slope, but I can calculate it. So this is what we learned in section 2.4. To find the slope using 2 points, we have this formula here. M equals y2 minus y1 over x2 minus x1. So let's go ahead and find the slope using these 2 points. We have x1 and y1 here. We have x2 and y2 here. We'll plug the numbers in the way we've labeled them. This is exactly the way we did this problem back in section 2.4. So we have y2, which is negative 10, minus y1, which is negative 5, over x2, which is negative 8, minus x1, which is negative 4. Right? And so be careful with that because all these numbers are negative. You have minus signs in the formula, a lot of negative signs going around. So you got to be extra careful with all those negative signs. Minus a negative is going to make that positive. And same thing here, minus this negative makes it positive. So what we have is negative 10 plus 5, which will be negative 5, over negative 8 plus 4, which will be negative 4. Now those numbers don't reduce, but the negative signs do cancel out. Negative divided by negative is positive, so my slope will end up being positive 5 over 4. All right, so that's the slope. So we had to calculate it this time. They didn't just tell us what it was, but we do calculate it, and now we can plug that in for m. We can plug in either point for x1, y1. Now I already have this one labeled as x1, y1, but that was for the purpose of finding the slope. That label doesn't have to apply when it comes to finding the equation. However, I still like this choice because the numbers are smaller. Now, I might choose the bigger numbers if they were positive. That might be a benefit to me. So you get to choose which point to use. Pick the one that's going to be the easiest to work with. And if I had a couple of positive numbers, even if they were a little bit bigger, I would probably prefer that to avoid the negative numbers plugged into this formula. But they're all negative. So really, I'm just going to use the numbers that are smallest because since they're all negative, there's no benefit to switching to the other point. So I will use this point here. And so I'll plug in negative 4 for x1, negative 5 for y1. And so let's plug all these numbers in. We get y minus y1, which is negative 5. So again, careful with the double negative. Equals m, which is 5/4, times x minus x1, which is negative 4. Which again, we have to be careful with that double negative. So let's take care of those double negatives first. This becomes y plus 5 equals 5/4 times x plus 4. And I really recommend doing that before you distribute, because especially if the slope is negative and you have the double negative here, that becomes really complicated and confusing, and I've seen students make mistakes with that. So simplify that first, then we'll distribute the slope, and we're going to get y plus 5 equals 5/4 x plus, what's going to happen here when 5/4 multiplies to 4, think of this as 4 over 1, the 4's are just going to cancel each other out. So let me write it somewhere out of the way. You'll have 5 over 4 times 4 over 1. The 4's are going to cancel out, so you just get 5 over 1 as a result, which is just the number 5. Right? And this one has kind of an unusual outcome. So now to solve this for y, we subtract 5 from both sides, and 5 gets canceled out from both sides. Right? These 5's cancel out. These 5's cancel out, so we just get y equals 5/4 x as our equation. All right, so that one was quite a bit more work because they didn't tell us what the slope was. We had to do some work to find it. And so that kind of adds some layers to the problem that we didn't see previously. And it's just going to get a little bit worse from here. So here's the next kind of problem that you'll have to deal with, where they're even more obscure with the information they're providing to make you do even more work to get what you need. So write an equation of the line containing the given point, which is 8, 9 in this case, and parallel to the given line. So instead of giving us 2 points to work with to find the slope, they're telling me about a line that is parallel to the line that I'm looking for. So I'm really going to have to go out of my way to find the slope that I need in order to answer this question. All right, the important thing to recognize in this problem, and if you don't recognize this, you're dead in the water, which is there are 2 lines that we're dealing with in this problem. And I find when I see students do this problem on the test, sometimes they don't seem to realize that. And so they think there's just, oh, this point 8, 9 gets plugged into this equation, and that's not the case. These are 2 separate lines, right? We have 2 different lines that we're dealing with in this problem. There's the line we're looking for, which I like to label with a question mark because we don't know that line. We're trying to find the equation for that one. And then there's the line we're given the equation of. And for the line that we're looking for, we know it contains the point 8, 9. Right? That's what it says in the directions. Find this equation of the line that we're looking for containing that given point. So that's for the line that we're looking for. And parallel to the given line. So this equation is the given line, x plus 2y equals 9. Right? And we know these 2 lines are going to be parallel, which we learned about in the previous section, 2.5. So to find this line over here, I want to use the formula y minus y1 equals m times x minus x1. But in order to get started with that formula, I need to know the slope. To find the slope, like in the last problem, we used 2 points, but they didn't give me 2 points here. So I don't have enough information about this line on its own to find the slope that I need in order to find the equation. So I'm going to have to use this other line that they gave me. So I can find the slope of this line by solving this equation for y. I'm going to get it in the form of y equals mx plus b, and then I can find the slope of this line, use the fact that it's parallel to figure out the slope of the line that I'm looking for. So that's the hoops we're going to have to jump through in this problem to find the slope. So solve this for y, we'll have to subtract x to the other side, and we'll get 2y is equal to 9 minus x, and then we will divide by 2 on both sides. And so we're going to get y equals, that 2, remember, divides into both of these. We've done this exercise before, earlier in the chapter. We get 9/2 minus 1/2 x, right? So the x goes off to the side. There's an invisible 1 in front of it, so you get 1/2 in front of the x, and it's negative because of that minus sign. So the slope here is negative 1/2, right? It's the number in front of x. So the slope here is negative 1/2. This line is parallel to the line that I'm looking for. So the slope of the line I'm looking for would have to be also negative 1/2, right? Because what we learned in the previous section, 2.5, is that 2 parallel lines will have the same slope. So if I know these lines are parallel, I know the slopes have to be equal to each other, right? So if the slope of this line is negative 1/2, in order to be parallel, the slope has to be the same. It has to also be negative 1/2. All right. So now we have the slope finally, and we have the point that we were given. We'll think of that as x1, y1. We'll plug all that information into this formula, and then we'll be able to find the equation of our line. So let's go ahead and do that. We have y minus 8 equals negative 1/2. Sorry, I did that wrong, so don't make the mistake I just made. Let's go back. Right. So what should I have put here? Should be y minus 9, right? I want the y coordinate here, equals the slope, which is negative 1/2, times x minus x1, which is 8. All right. Very good. So we plug the numbers into this formula. The slope m is equal to negative 1/2. x1 is 8. y1 is 9. So that's what we did. We plugged all those numbers in. Now we can simplify this. So I have y minus 9 equals, we'll distribute the negative 1/2. So we get negative 1/2 x. Negative times a negative will make that positive. And, there's a fraction here, but you could also think of it like this, especially for a simple fraction like 1 over a number. You just want half of 8. What is half of 8? 4. Right? So essentially that bottom number tells you what to divide by. This is just 8 divided by 2. And whenever a fraction is 1 over a number, that's all it is. It's just a division. So if you were multiplying by 1/4, you're just going to divide by 4. If you're multiplying by 1/8, you divide by 8. Right? So 8 divided by 2 is what gives me 4, and it's going to be positive because negative times a negative is positive. And then we'll solve for y by adding 9 to the other side, and I think we'll have just enough room to get the answer on the screen here. We'll have y equals negative 1/2 x plus 13. All right, and then that's what you will type into the box. Now this time, notice they kind of switched it up on us. They don't have the y equals 2 on the screen, so we need to type that part into the box as well. So you want to type y equals negative 1/2 x plus 13 into this box. All right, so make sure you get the y equals 2 this time. Okay, so this problem here is very similar to the one we just did, except this time it's perpendicular instead of parallel. But it's the same exact kind of problem. Write an equation of the line containing the given point and perpendicular to the given line. So again, I recommend setting it up to make it clear you're dealing with two different lines here. You have the line that you're looking for the equation of, the line you're given the equation of. For the line that I'm looking for, I know the point 8 comma negative 7. For the line I'm given, I have the equation 6x plus 7y equals 8. Before I can get started finding the equation of this line, I need to know the slope. I won't be able to find it with the information just about this line that I'm looking for, so I have to use this other line where I was given the equation of to help me out. And I guess the last thing I probably should have marked here, I should have done already, is that these two lines in this case are perpendicular. Right. So just like we did in the last problem, to find the slope of this given line, we'll have to solve it for y. So I'll subtract 6x to the other side to get that process started. We'll have 7y equals 8 minus 6x, and then we will divide by 7 on both sides, and we will get y equals 8 over 7 minus 6 over 7x. So the slope here is the number in front of x, which is negative 6 over 7. All right. So that's the slope of the line that I was given, but this time that is not the slope that I'm going to use in my formula to find this other line, the equation of this other line, because this time it's perpendicular. What would the slope of a perpendicular line have to be then? It's going to be not negative 6 over 7, it'll be 7 over 6. Right, so what we learned about perpendicular lines in 2.5 is that perpendicular lines will have slopes that are negative reciprocals of each other. So to get the slope of a perpendicular line, you'll flip the fraction over, so 6 over 7 becomes 7 over 6, and then you take the opposite sign. So this slope over here is negative, which means the slope of my perpendicular line should be positive. So that's how I'm getting the slope for this line that I'm looking for the equation of. So now that I have that slope and I have this point, I can label this as x1, y1, and I'm going to plug all of that information into this formula again. Y minus y1 equals m times x minus x1. All right, so we'll get y minus y1, which is negative 7, equals m, which is 7 over 6, times x minus x1, which is 8. All right, so we plug all those numbers in. This one I can tell because that fraction and that number are not going to interact very well. This is going to be kind of a messy answer. So we'll have y plus 7 equals 7 over 6x minus, so just like we did before, think of this as 8 over 1. If you need to, work it out on some scratch paper off to the side. But what's going to happen is you multiply straight across and you will get 56 over 6, which reduces. I probably should have reduced it first. Maybe let's go back. Let's just kind of redo that, because what you can do is, because 6 and 8 reduce with each other, you can do that before you multiply the numbers together. So think of this as 3, think of this as 4, right? So divide a 2 out of both of these, and what we end up with, the reduced form, will be 28 over 3. It's the same thing as 56 over 6. Maybe I should have just left it the way it was. And then that reduces to 28 over 3 because you divide a 2 from the top and bottom to get that. And you want to keep the fraction as small as possible, right? You want the numbers in the fraction to be as small as possible. Okay, so now we will solve for y by subtracting 7 to the other side. And so we'll get y equals 7 over 6x. And so I need to work this out. Think of this as 7 over 1. I think I will do this on some scratch paper off to the side. We have 28 over 3 minus, I'm going to multiply a 3 to the top and bottom to get a common denominator. So it'll be 21 over 3. And then we will subtract these. They're both negative, so they'll combine together to give me 49 over 3. And it'll be negative, right? So negative 49 over 3 is what I'll get here. 49 over 3. And there's my equation. All right. Now this time, again, I don't know why they keep switching back and forth. The y equals is already on the screen. So this time you would only need to type in the right half of that equation into the box. All right. So let's see. We have one more problem to do here of that type. And then we have a couple of word problems, some application problems that we're going to look at. So if you haven't been doing this already, this might be a good opportunity because this is really a very similar problem to one we just did. Pause the video, try this problem out yourself, see if you're able to work through that problem and get to an answer, and then resume the video to see if you did the problem the correct way. All right. So what you should find when you do this problem yourself is you'll set it up the same way that we did the previous two. The point we're given here is 0, 4. The line that we're given the equation of is 8x plus 5y equals 3. And we know these lines are perpendicular again this time. So just like the last problem, they're perpendicular, which means the slopes will not be the same. They will be negative reciprocals of each other. I need the slope of the line that I'm looking for. I can't figure it out from this information, so I'm going to use the line I was given to figure out the slope. We'll start by solving this for y. So just like we did the last two times, this is going to work out in a pretty similar fashion. And it's going to be a little bit messy here. So you subtract 8x to the other side, divide by 5. Yeah, and this is not a very pretty equation, but that's okay. We get 3/5 minus 8/5 x, which gives me a slope of negative 8/5. Whoops, negative 8/5 for the line that I was given, but because it's perpendicular to the line I'm looking for, the line I'm looking for has to have a slope of 5/8. Right, so really pretty similar to the last problem that we did. Now what's different here, and I don't know if you would have noticed the shortcut, because I think that's why I have this example on here, because otherwise it's just a repeat of the problem that we just did. This point, it doesn't tell you, but hopefully you could recognize the x-coordinate is 0, so this point is the y-intercept. So I don't need to use the y minus y1 equals m times x minus x1 formula. You can. It's not wrong to do that. If that's what you did, you can still get the same answer from that. It's just a little bit more work. Since I have the y-intercept, I'm going to switch back to using this formula. Y equals mx plus b. And m is equal to 5/8. And because I was given the y-intercept, that tells me b, right? B is equal to 4. And so that's the answer. That's the equation. So if you did it the other way with the point slope formula, like I said, it might be a little bit more work, but you would end up with the same exact answer if you did everything correctly. All right. So let's take a look at a couple of these application problems here. So in 1920, the record for a certain race was 45.2 seconds. In 1970, it was 44.7 seconds. Let r of t equal the record in the race, and the variable t be the time of year. Sorry, I said the time of years. It's the time, but it's the number of years since 1920. Part A says to find a linear function that fits the data. So as soon as you see the word linear, you should immediately think of y equals mx plus b. Right? Because that's a linear equation. That's a linear formula. So if they tell you the relationship's linear, that's the first thing you should think of. Or, and I think this will be the better one to do here, but in other cases you might find it's easier to use this formula. But you should immediately think of one of these two formulas. Right? And you want to fill in the details of this formula, which means the first thing you'll need to do is to find the slope. So whichever formula you're going to use, you need to know the slope first. To find the slope, I need 2 points, right? Or I need another equation to work with, but this problem is not going to give me a second equation. It's only about this one equation, so I need to find 2 points. So in 1920, the record was 45.2. So 1920 should give me the time, and the record here is my variable r. Right? In 1970, that's again a time. The record was this. So there's 2 points right there. If I pair these together, that gives me 1 point. If I pair these together, I get another point. Now, we want t to be the number of years since 1920. So 1920, what's the number of years since 1920 for the year 1920? It's 0 years since 1920, right? It's right on the dot that year. So the time we're measuring is from the year 1920. And if we're in the year 1920, the time that has passed is 0 years, right? Comma, the record, which is 45.2. All right, so that is our first point. The second point is 1970. So again, t is the number of years since 1920. So for 1970, it has been 50 years, right? 50 years has passed since 1920. And the record in that year was 44.7. And so that gives me a second point that we can pair together. Using those 2 points, we can find the slope. So I guess I need to probably do this down here. So we have m equals, we have y2 minus y1 over x2 minus x1. Now I know the variables we're using are not x and y this time. We're using t and r. But for the purposes of the formula and for using 2 points, I leave it as just labeling. How do I want to say that? I'm just going to leave the label as x and y for the points and for finding the slope. Now when I set up the equation, I'm going to be using the variables they want me to use. So this is my first point. I'll label this as x1, y1. This is my second point. I label it as x2, y2. Let's plug the numbers in the way we have them labeled. So y2 is 44.7 minus y1, which is 45.2, over x2, which is 50, minus x1, which is 0. So we need to simplify that. Let's see, I have a calculator right here. And so we'll have 44.7 minus 45.2. That gives me, this works out really nice, negative 0.5 over 50 minus 0, which is 50. And so my slope will be, dividing that by 50, it's a decimal number, but it's not a bad one, 0.01. Right, so that's my slope, negative 0.01. Now that I know my slope, I'd like to also point out to you that we also know the y-intercept. Because of the way they wanted to set up the variable t, this point ends up becoming your y-intercept because the x-coordinate is 0. That's the y-intercept, which tells me that this is equal to b, right? b is 45.2. So I'm definitely going to use this formula since now I have the slope and I have the y-intercept. I can just plug those numbers into this formula and be done with it. The only other change I need to make with this formula is the variables. So instead of y, they want me to call this r of t. So remember, the function notation is always your y variable. So this is going to be r of t equals m, which is negative 0.01. And instead of x, they want me to use my variable. They want my variable to be t. So we'll have t here plus b, which is 45.2. That's my y-intercept. So that's the answer for part A. All right. For part B, use the function in A to predict the record in 2003 and 2006. I think I will just do one of those because I'm running out of space for one thing, but once you do one, the other one's going to be pretty much the same process. So I think you'll be fine figuring it out. So let's just do 2003. That's a time, right? But the variable t is how many years have passed since 1920 for this particular year, and that'll be 83 years, right? So 1920 to 2000 would be 80 years, and then 2003 would be another 3 years. So that gives me t is equal to 83. Let me see if I can undo that. Oh, it's not letting me. Okay. No, it's really not letting me. Okay. And if you're going to do this variable here, I'm sorry, I kind of marked on that number, but it won't let me undo it because I think I find this software program, when I write too much on the screen at once, it starts to really lag, which is what it's doing right now. This will be 86, right? So that's how you get the time for that. So I apologize if it gets a little laggy here. So for part B, what we're going to do is plug this variable in for t and use this equation to make a prediction what the record is going to be in that particular year. So we'll have r of 83 equals negative, sorry, again, it's kind of lagging, 0.01. I have to slow down a little bit here so you can keep up with me. Plug in 83 for t plus 45.2. And so we can plug all that into a calculator. So I'm just going to do that on my calculator now. So I have negative 0.01 times 83 plus 45.2. And what you should get when you plug that in your calculator is 44.37 is what I get. Now, I don't see the directions on here, but they might say something like this: round to the nearest hundredth, which is 2 decimal places. Now, my answer comes out to 2 decimal places, so that works out perfect. But if it said round to the nearest tenth, you would round that to 0.4. But this is what it is to the nearest hundredth. Right? So that'd be my answer for 2003. For 2006, I'd plug in 86 here, and I'd get a slightly different answer. Now, for part C, I'm really out of room here. It's the same idea, but the reverse. We want to find the year when the record would be 44.26. So they're telling me the record, which is the y variable, and they want me to work backwards to find the x variable. So I'm sorry, it's a mess on this screen right now, but I'm going to try to squeeze it in the only space that I have, which is right here. So we're going to plug in 44, if it'll let me, right, okay, 44, oh gosh, 0.26, that's my y variable, equals negative 0.01, sorry, this isn't working out too good, x, sorry, it's not x, it's t, it's not letting me undo, oh gosh, it did that time, okay, t plus 45.2. Whoops, I put 2. 40. Let's try it one more time. Undo, please. Okay. All right, there we go. Okay. 45. I can't make any mistakes because it's hard to correct it. All right. So you plug that in for y. So in place of the r of t, that whole thing gets replaced with 44.26. The right-hand side of the equation stays the same. And now you want to solve this for t, which I don't have a lot of room to do. And plus, the screen's getting really laggy here because of all the writing I have on the screen. But you'll start by subtracting the 45.2 to the other side. 45.2. All right. And so let's see what we get from that. We have 44.26 minus 45.2. And we get negative 0.94. Oh, I'm sorry, this is really going to add a lot of time to the video. That's a 9 and then a 4. I don't know if it's going to let me write that. Oh, it just made it worse. Okay, let's try to undo it. Sorry, I can't leave it like that. Oh, wow, it's really laggy. Okay. Not letting me undo. Okay. Okay, that's okay. I'll do this one again. Okay. So 94 equals negative point, we're almost done, 0.1t. I'm leaving off the leading 0. It doesn't really need to be written there. And so I think you know the last step. You probably have already finished the problem. We divide by negative 0.01 on both sides. 0.01. And so I'll do that in my calculator, divide by negative 0.01, and we get 94. All right, so we'll get, I'm sorry, it's really messy here, but we get 94 for t. If it'll let me write it. Okay. Now, last thing is, that's not the final answer to part C. It wants to know the year. This is the amount of time that has passed since 1920. So 94 years have passed. So we want to add that to 1920. Okay. And so I'm going to add that to the year 1920 to find that this will be in the year 2014. Okay. All right, we got there finally. Okay, so that is the answer for part C. So I apologize. So there's part C right there. Okay. Okay, so again, I'm sorry about how laggy the program was being and the poor planning on my part in utilizing the space that's on the screen. We have one more example here and then we'll be done. And hopefully the lag will stop since we're moving on to a new problem with a blank screen. The Technology Center bought a fax machine for $625. The fax machine depreciates at a rate of $25 a month. Find a function f that can be used to determine the value of the fax machine t months after purchase. Now this time it doesn't tell us that it's linear, but what else could it be at this point, right? We haven't really talked about other types of equations, and the section we're working on is finding linear equations. So kind of based on those clues, you know this is going to have to be a linear equation. But if you didn't have those clues and you just had this problem out in the wild, how would you know a linear equation was the appropriate one for this situation? And it has to do with this part right here, the $25. It says a month, but really this is per month, right? This is $25 per month that it depreciates. And whenever you see the word per, that is always a linear equation. There's always a linear relationship involved if you have the word per in the description of whatever you're working on, right? And so as soon as I see that it's linear, my first thought is y equals mx plus b, right? Or again, the other formula that we might possibly use, the point slope form, but this time, again, you're going to want to use y equals mx plus b. It'll be the easier one to use. Now, the first thing I need to find is the slope. And here they don't really give me a lot of points. But what they do tell me is that the fax machine originally cost $625. That's at the very beginning, right? That's when it's brand new. So the time that it's been used is 0, right? It's been used for 0 months. So at the time 0, the time it was purchased, the value of the fax machine is what you paid for it, which is $625. And then it depreciates by a rate of $25 per month after that. So after 1 month, it loses a value of $25, so now it's only worth $600. After 2 months, it loses another $25 in value, so now it's worth $575, and so on and so forth. And so this gives you plenty of points to work with, so you can make as many points as you want. We'll just use the first two to find the slope. So we have x1, y1, and x2, y2. And I think you're going to be surprised by this answer, right? So we have y2 minus y1 over x2 minus x1. We'll plug these 2 points in the way we've labeled them. So we're going to get, I don't know if I have enough room up there. We'll do it right here. y2, which is 600, minus y1, which is 625. I'm getting ahead of myself here. 625. Over x2, which is 1, because it's been 1 month, minus x1, which is 0. And so this is going to give me negative 25 over 1, which is negative 25. Where have we seen that number before? It's this number right here. So really, they told you the slope. It's just you have to be able to recognize that's what they've given you. So I really did not need to calculate the slope. The slope was given to me by this number here. So whenever you see the word per, not only does that tell you it's a linear equation, that also tells you what the slope is. Whatever number goes with that word per is going to be your slope. But you do have to be careful about should that be a positive or a negative slope depending on the situation. It's going to be negative this time because the fax machine is losing value, so it will be a negative slope. If it was gaining value, like if it was a collectible that increases in value over time, then the slope would be positive. It'd be positive 25, right? But in this case, it's negative 25 because it's depreciating. So that's my slope. I'm going to plug that in for m. So I'll have y equals negative 25 x plus b, which again we are given. It's the initial value of the machine. So this problem actually tells you everything you need to put your linear equation together without having to do any computations. They tell you the slope, right? This ends up being the slope right here. And they tell you the y-intercept because the initial value will be the y-intercept. So it's 625. Now they don't want me to use x and y, so I'm sorry, I forgot to change those out. So instead of y, they want me to use this function notation, f of t. And so we have negative 25. And instead of x, they want me to use t. But all the numbers are going to stay the same and stay in the same place, right? And so that would be my equation for the depreciation of this fax machine. And that's part A. Now I don't see parts, I don't know how many parts there are if there's B and C, but I assume probably part B is what's the value of the fax machine after blank number of months. So let's just go ahead and make up a number and do an example of that. So part B is going to be something like this. What's the value of the fax machine? So find F when how many months have passed? Let's just say 15 months, after 15 months. All right. And so what you're going to do is use your equation you've just established, take the number of months they give you, plug it in for T, and then you can find F. So I have F of 15 equals, negative 25 times 15 plus 625. And we'll plug these numbers into a calculator. So I have negative 25 times 15 plus 625, and we get 250. So after 15 months, the fax machine would be worth only $250 at that point. All right. And there might be a part C where it tells you the value of the fax machine, which you plug in for F, and then you have to solve for T. But we did an example of that in the last problem. So I think I'll just go ahead and stop there. However, if you do have any trouble with this problem, if it does have a part C and you're having trouble figuring it out, use the Math Excel help. You can click on view an example, or send me an email if you have any further questions. All right, so that concludes 2.6, finding linear equations.